In the last class, we discussed about the classification of states, and we classified the states into transient and recurrent on the basis of first return probability, that is this expression f I that is equal to summation f I n going from 1 to infinity. If f I is less than 1, then this state is transient. If it is equal to 1, then this state is recurrent. Now we will establish a relationship between first passage or first entrance probability at instant n and the n step transition probability Pij n. So the relationships are Pij n, that is n step transition probability, is equal to summation Fij m into Pjj n minus m going from 1 to n. Similarly, for transition from I to I, that at n step transition probability from I to I, that is also related to that is Fii m into Pii n minus m going from 1 to n. So that means this expression, if I notice that it goes to state j for the first time at instant m, and then there is a jump from j to j in n minus m. So transition from j to j in n minus m, that way we can interpret. How to prove this? This chain is at state j can be written as the union of disjoint events as. So what we can write? Xn is equal to j, this is the event. So this can be expressed as the union of the disjoint event, that is Xn is equal to j, Xn is equal to j intersection with the disjoint event, that is Xm is equal to j, this is the event we can write Xm is equal to j, x m minus k is not equal to j, k is equal to 1, 2, etc. up to m minus 1. Okay. So that way we can write event x n minus j as the union of events, disjoint events, that is this union from m is equal to 1 to n. So m is equal to 1 to n of the events, x m is equal to j, x of m minus k not equal to j, k is equal to 1, 2 up to m minus 1. So this is the partition we do. So that way now this probability Pij n can be written as P of x n equal to j, given that x0 is equal to I. So this we can write as, now we can use this, and these events are disjoint, therefore probability will be summed up. So we can write this is sum of the probabilities with m going from 1 to n. Probability of x n is equal to j, x m is equal to j, x of m minus k is not equal to j, k is equal to 1, 2 up to m minus 1, given that x0 is equal to I. Essentially we are writing the probability of this event given x0 is equal to I. Now this we can write, so we can write probability that we will consider this as the first event, probability that xm is equal to j, x of m minus k not equal to j, given that k, for k is equal to 1, 2 up to m minus 1, given that x0 is equal to I. So this is the first probability we are considering, multiplied by the, now we will consider the conditional probability that xn is equal to j, this xn is equal to j, given that xm is equal to j, x of m minus k not equal to j, k is equal to 1, 2 up to m minus 1 and x 0 is equal to I. Now, recall the definition of first entrance probability. So, this quantity probability that xm is equal to j, x of m minus k not equal to j for k is equal to 1, 2 up to m minus 1, given that x 0 is equal to I. This is the probability that this chain will visit state j for the first time, given that x 0 is equal to I. So, that way this is f I j m into, now we will be using the Markovian property, probability that x n is equal to j, given that x m is equal to j, because according to Markov property this is the recent past. So, this will be simply probability of x n equal to j, given that x m is equal to j. So, this term is n minus m step transition probability. So, that way we can write p j j n minus m. Thus, what we have derived? We have derived that probability of I j n, n step transition probability is equal to sum of the product of f I j m into p I j n minus m. Here again we are I comma j and I j, we are using this in the same sense. So, that way this is a convolution sum. If we notice carefully that this is a convolution sum of this sequence, that is first entrance probability sequence and the state transition probability sequence. Similarly, we can same way we can establish that p I I n is equal to, there will be first, for the first time from I to I there will be a transition in instant m, f I I m into, then there will be transition from I to I in n minus m step, p I I n minus m. So, that way for p I I n also we can express it in terms of f I I m and p I I n minus m. Okay. So, this way we established the important relationship. This is the important relationship. So, that we will be used for in our next analysis. Now, these expressions are convolution sums, therefore, they are better analyzed in the transform domain. We will be using here that generating function. Suppose generating function, suppose we have a sequence a n, n is equal to, suppose n is equal to 0 to infinity, and assume a n is greater than equal to 0, non-negative we are assuming, and we define a z. This is similar to z transform, that is equal to a n z to the power n, n going from 0 to infinity. So, this is the generating function, generating function. Okay. So, if a z is convergent for mod of z is equal mod of z less than 1, then there is something called Abel's theorem, Abel's theorem or Abel's lemma. According to that, what we can get is that limit of a z, z tends to 1 minus, that is equal to a 1. So, that is one result, and another result is similar to this, also can be derived from this Abel's theorem, that that is limit of this sequence a n as n tends to infinity is equal to limit z tends to 1 minus, that is 1 minus z into a z. This is what is known as the final value theorem of Z transform. This is similar to final value theorem of Z transform. As a corollary of this theorem, we also get that limit of a n as n tends to infinity is equal to limit z tends to 1 minus of 1 minus z into a z. So, this is similar to the final value theorem in Z transform. So, that way this result we will be using for analyzing the convolution sum relation for first spaces probability and state transition probability. So, that way we will be analyzing using the generating function this expression as we have already explained. Generating function here that is the Pij z is equal to z to the power summation n going from 0 to infinity z to the power n Pjj n, and similarly. So, Fij capital Fij that is the generating function for Fij n, and that is equal to summation z to the power n Fij n going from 0 to infinity. From this relationship, now since this is a convolution sum, we in the transform domain we will get Pij z is equal to Fij z into Pjj z. And if I consider the transform relationship from this expression, so what we will get, that is Piij is equal to Fiij into Piij. So, these two relationship we get, from that we will get Piij is equal to 1 by 1 minus Fiij. Okay. From this, if I take Piij this side, I will get this result. And from this, now here Pjj z, so for a same state if we consider, then I can get a relationship similar to this. So, we get Piij z is equal to 1 by 1 minus Fiij. Now, this Piij z we can write as that is Fij z into Pij z. We get that Pij z is equal to Fiij z into Pjj z. Now, this quantity Pjj z, using this relationship we can write it as Fij z, and this is using this relationship, this will be 1 minus f of jj z. Okay. This relationship if we use for state j, we will get like this. So, that way we established this relationship and this relationship. Our aim is to find out what happen as z tends to 1. So, in that case I can apply the Abel's theorem. So, what I will get, that is A1, that is like here, that is Pin z to the power n, z I will put as 1. So, that must be equal to 1 by 1 minus Fi I. So, this expression is equal to 1 by 1 minus Fii 1, Fii 1. So, this Fii 1 is nothing but that is if I put this expression, suppose this is for ii, if I consider and put z is equal to 1, in that case this Fii 1 is nothing but that is the summation of this quantity is summation Fi I n going from 0 to infinity. So, that is equal to, we define it, we have already defined it as Fii. So, that is why this is equal to 1 by 1 minus Fii. We will be using this expression, that summation Pii n going from 0 to infinity is equal to 1 by 1 minus Fii. So, this relationship we will be using to derive an important theorem. So, a state I is transient if and only if summation Pii n n going from 0 to infinity is less than infinity, that is this sum is convergent. We have already established this quantity. If the state I is transient, then f I is less than 1, then this quantity will be 1 minus this is less than 1. So, this will be a finite quantity. So, therefore, the left hand side will be convergent, because this quantity will be finite. Conversely, if this is less than infinity, summation p I n going from 0 to infinity is less than infinity. So, this left hand side is less than infinity. This will mean that 1 minus 1 by f I that is also less than infinity. So, this will mean that 1 minus f I is greater than 0, implies that f I is less than 1. Therefore, state I is transient. Therefore, state I is transient if and only if this summation p I n going from 0 to infinity is convergent. Now, since this is a convergent series, it also follows that if state I is transient, limit of p I n as n tends to infinity will be always equal to 0. So, this n step transition probabilities of the transient states as n tends to infinity will become 0. Since it is a convergent series, from this it immediately follows. Now, from the same expression, now what happened here, if f I is equal to 1, that means if state is recurrent, then this term will become infinite. Therefore, this left hand summation will become infinite. So, therefore, what we can state that a state I is recurrent if and only if p I n is equal to infinity, because if it is less than infinity, then it is transient. Therefore, it will be recurrent from this expression, that is from this expression, earlier expression. So, summation from this expression, summation p I n going from 0 to infinity is equal to 1 by 1 minus f I. Now, for recurrence, this f I must be equal to 1. So, for that this sum will be infinite, because if it is 1 by 0, that will tend to infinity. So, that way a state I is recurrent if and only if this summation is infinite, and if this summation is finite, this state will be transient. Let us do the steady state analysis. We have already proved that for a transient state, that p I n as n tends to infinity is equal to 0. Now, let us see what happened to p I j n as n tends to infinity. For this, we will consider the relation p I z is equal to f I j z divided by 1 minus f I z. So, this relationship already we have derived from the convolution sum of the state transition probability and first passage probability. Now, we can apply the final value theorem similar to the final value theorem of Z transform. So, what will happen, p I j n as n tends to infinity, limit Z tends to 1 minus, because region of convergence is inside unit circle, of 1 minus z multiplied by p I j z. Okay, I am multiplying this by 1 minus z. So, that way we are getting as z tends to 1 minus. So, we are substituting this, and when I put z is equal to 1, so here we will get 1 minus z we will get, and this will be f I j 1 is simply f I j. So, what is f I j? F I j is equal to summation f I j n going from 0 to infinity. And similarly, so we have derived this relationship earlier also. And now what happened as n tends to infinity. So, I will put z is equal to 1, this term will become 0, provided this term is less than 1, then this term will be finite. Okay? If the state j is transient, then fjj is less than 1, this fjj is less than 1. Therefore, what will happen to limit of pij n? Limit of pij n as n tends to infinity will become, this is if I put z is equal to 1, this term will become 0. So, that way what we get is that for a transient state, if state j is transient, then any transition and step transition probability to this state as n tends to infinity will become 0. P I j n limit of this as n tends to infinity will be equal to 0. So, for a transient state j, any state transition probability and state transition probability as n tends to infinity will become 0. So, we discussed the steady state transition probability and step transition probability as n tends to infinity for the transient state. But for the recurrent state, the same analysis is slightly difficult. We will do it here. So, here we will consider the relationship Piij is equal to 1 minus 1 by 1 minus Fiij. Suppose state I is recurrent. We can apply the final value theorem again. So, limit Pii n as n tends to infinity, that is limit of z tends to 1 minus z into Pii z. So, if I put again the value of z is equal to 1, we will get limit of 1 minus z into 1 by 1 minus Fii. Now, we see that here if Fii is 1, because state I is recurrent, then this will become 0 by 0 form. So, we can apply the L'Hopital rule. So, we will get this limit Pii n as n tends to infinity. Now, what will happen? That we have to take the derivative of this expression with respect to z, and then this expression with respect to z. So, that way derivative of 1 will be 0 and derivative of z will be 1. So, and similarly here it will be derivative of 1 will be 0 and here it will be Fii derivative at z. So, that way we will take the derivative, and as z tends to 1 minus, we will get this is equal to, because here 1, and then denominator will be Fii dash 1, Fii dash 1. Now, this quantity, if we consider the generating function, so our generating function was Fiij is equal to summation Fii n z to the power n going from 0 to infinity. So, if I take the derivative Fii dash 1 at point 1, that will be equal to, now here if I put derivative here, z to the power n will be coming from n. So, that way n is equal to 0 to infinity n Fii n, and z to the power n minus 1, there z if I put 1, I will get 1 only. So, this is nothing but the this is the mean first and return time. So, because for the first time it comes to state n with this probability and multiplied by corresponding n. So, that way if we sum up, that will give me the mean first return probability, that is this quantity mu ii. Therefore, what will happen, that probability of n step transition probability as n tends to infinity, that will be equal to the reciprocal of mean first return time. So, this is one important result we have observed. Similarly, let us see Pij n, limit of Pij n as n tends to infinity for a recurrent state J. Suppose state J is recurrent, then what happens to this limit? Considering the relation again, this Pij z is equal to Fij z divided by 1 minus Fj z. So, if I put limit of Pij n as n tends to infinity is equal to that is limit of z tends to 1 minus of 1 minus z into Fij z divided by 1 minus Fjj z. This is by finite value theorem. So, by applying the L'Hopital rule, similarly for a recurrent state J, we can show that limit Pij as n tends to infinity is equal to Fij divided by mu Jj. So, here when we apply the L'Hopital rule, we consider that this is a product of two terms 1 minus j into Fij z. Therefore, while taking the derivative, we have to consider the that is derivative of the product rule. So, that way we arrive at this relationship. For a recurrent state J, so we have already derived for a transient state, but for a recurrent state J, this limit of the n step transition probability as n tends to infinity is given by Fij divided by mu Jj, where Fij is the first passage, eventual first passage probability, that this chain will eventually pass through state J given that initially at state I. So, that way this expression is equal to Fij and n going from 0 to infinity. But we do not know what will happen to this quantity Fij for a recurrent state J. So, that we will be discussing in the next class. So, what we have discussed in this lecture, let us summarize. So, we derived one important relationship, the state transition probabilities and first passage return probabilities are related as this. Pij n is equal to, that is the convolution sum Fij m into Pjj n minus m, m going from 1 to m. Same is true for Pii n. Now, a state I is transient if and only if the sum of Pii n going from 0 to infinity is less than infinity. So, a state I is recurrent if and only if the sum Pii n going from 0 to infinity diverges. So, here also we established if the state I is transient, then by definition Fjj is less than 1. This again implies that limit of Pij n as n tends to infinity is equal to 0. So, this is, that is, any transition probability to state J as n tends to infinity will become 0 if the state J is transient. So, if state I is recurrent and if the steady state probability exists, here we have assumed that the steady state probability exists, only then we can apply this formula. So, limit of Pii n as n tends to infinity is equal to 1 by mu ii. Now, for any recurrent state J, limit of Pjj n as n tends to infinity is equal to Fij divided by mu Jj, where mu Jj is the mean recurrence time to state J. Thank you.